May, June 2021, October, this paper 4, variant 1. We'll do the organic chemistry question. Normally, the last question is there. Okay. The first part, it is about empirical formula. We did yesterday how to work out the empirical formula. So many organic compounds which contain carbon, hydrogen, and oxygen, they mention it contain carbon is 48.65%, hydrogen is 8.11%, and oxygen is 43.24%. The first step, divide by atomic mass. So this I'll divide by 12, this I'll divide by 1, and this I will divide it by 16. So 48.65. So 48.65 divided by 12, that is equals to 4.05. So this one is 4.05, this one is 8.11, and the last one is 43.24 divided by 16, that is 2.7. The second step is divide by the smallest value, so which in the combination, so which one is the smallest value? So 2.7, we have the values 4.05, 8.11, and 2.07. 2.70. So the last value 2.70, what we'll do, we'll divide all of them by 2.7. This also 2.7 and this also 2.7. So 4.05 divided by 2.7, that is 1.5. So this is 1.5, 8.11 divided by 2.7, that is 3, and this will be 1. As I mentioned, one of the value in the combination is 1.1, 1.5, 2.5, 3.5. We multiply all of them by 2. So this will be 3, this will be 6, and this will be 1. So the empirical formula for compound is C3H6NO. So this is the empirical formula of this compound C3. H6 and O2. Sorry, I multiply this by 2, so it should be 2. So C3H6 and O2. That is the empirical formula. Then how to work out the molecular formula from an empirical formula? This part we will discuss today in the class, but I will just explain the idea. There's a formula to get molecular formula from empirical formula. Actually the molecular formula is empirical formula multiplied by n. This is to find the molecular formula from empirical formula. And what is n here? N is equals to molecular mass divided by empirical mass. So molecular mass is given 32. And empirical mass, empirical mass from empirical formula. So empirical mass, how to work out the empirical mass of CH4NO. So it contains 1 carbon, so 12. It contains 4 hydrogen, so 4 will be there because 1 into 4. Plus it contains one oxygen, so 16. So 16 plus 4, 20. 20 plus 12, 32. So it is 32 divided by 32. So what is the value of n here? The value of n is 1. So molecular formula is equals to empirical formula multiplied by n. So empirical formula is CH4O, and what is the value of n? Value of n is 1. So when we multiply, we'll get the same molecular and empirical formula. So this is a way to calculate the empirical formula of a compound. But we will do more examples, as yesterday I just explained to you how to get empirical formula. But the next step was to find a molecular formula from empirical. So this is how we work out. This part today we'll discuss in the session. The compound X and Y have a same general formula. X and Y both are carboxylic acid. X has a molecular formula of H4O. Y is having a molecular formula C4H8O2. Deduce the journal formula of X and Y. Like how I can generalize this, how I can make a journal formula of, by using these two. So you can see this contain O2, this also contain O2. So O2 is same. Like the other group also will have the same O2. But what about relation between carbon and hydrogen? So what relation you find between carbon and hydrogen? If carbon are 2, hydrogen are 4. So it means the number of the hydrogen are twice. When carbon are 4, hydrogen are 8. So again, the number of hydrogen are twice. So how I can relate the carbon and hydrogen with each other? So I can say if we have n hydrogen, if we have n carbon, then we will have 2n hydrogen. Like, or if we have x carbon, like if carbon is x, the hydrogen will be 2x. And they all contain O2, so they will be O2. So general formula is CnH2nO2. Then draw the structure of a compound Y and show all the bond. What is compound Y? As you can see, compound Y contain 4 carbons. So I have to, and they already mentioned they are carboxylic acid. So I have to draw butanoic acid. So for carboxylic acid, the functional group is C double bonded with O, O and H. That is the functional group. And there should be 4 carbons, so including this, one is already there. So 2, 3, 4. And then we have to put the hydrogen. So this will have 3 hydrogen because one bond is there. This will have 2 hydrogen. This will have 2 hydrogen. What is the name of this compound? Name of this compound, 2 carbon atoms are there. So it will be but because of 2 carbon. And because they have a single bond. And due to this functional group C double bonded with O and OH, so it will be oic acid. So it is butanoic acid. Then give the name used to describe the family of similar compound. So this is which are having a similar chemical property, same functional group. So we call them as homologous series. So this is always the name given to a compound which belongs to same class. Like all alkanes refers to homologous. All alkenes also homologous. Propene is unsaturated. Unsaturated means it contains carbon-carbon double bond. The formula for propene is CH3, CH and CH2. The color change which we observe if it is added to aqueous bromines. So it is the same question we did yesterday. Whenever alkenes, we add aqueous bromine, so original color will be orange and then it will decolorize, so it will be colorless. The next part, propene can be produced by cracking a long chain alkane. So if we have a long chain alkane, we can make propene by cracking it. Pentadecane, which is C15H32, is cracked to produce an alkane and propene at a ratio of 1:2. Like it produces 2 molecules of propene and it can produce 1 molecule of another alkane. So propene, prop means 3 carbon and it is ene. So if it will be C3, how many hydrogen should be there? 6, because the number of the hydrogen in alkene are always twice as compared to number of carbon atom. So the formula will be C3H6, that is propene. And they mention it produces 2 moles, two molecules of propene and 1 molecule of alkene. So what will be that alkene? There are 15 carbon atoms. Out of 15, 2 multiplied by 3, 6 are used. So we are left with 9. So it will be C9. And how many hydrogen are used here? 6 multiplied by 2, 12 are used. And total 32 are there. So how many hydrogen? It will be 20. And even I can count in this manner, or even I can use the idea that if it is an alkane, the number of the hydrogen are always twice plus 2. And if it is alkene, the number of the hydrogen are always twice. So here, because it's an alkane, the number of the hydrogen should be twice plus 2. So 19 multiplied by 2 is 18, plus 2 makes 20. And this one is alkene, so the number of hydrogen are always twice. compared to carbon. So 3 carbons, so it will have 6 hydrogen. Then propene can be converted to make into polypropene. Name the type of polymerization occur. Remember, in alkenes, what kind of polymerization occur? It gives an addition polymer. Then we have to complete a diagram for a section of a polypropene. Now, how to complete a diagram for this? As I mentioned, whenever I'm drawing a polymer, I should rearrange my structure. Like this is propene. This one is propene. But whenever we draw a polymer, if we want to draw a polymer, what we have to do, we have to rearrange the structure of a monomer first. So then how the monomer should appear? C double bonded with C, 2 bonds up, 2 bonds down. And it is propene, so CH3, CH, H, and H. So this is also propene. And then to draw a condensation, to draw an addition polymer, what we do? We draw the same structure, but without a double bond. And we link them together. And this will be the long chain compound. So we just have to complete the structure like this part here, and this is the second part. So it will be CH3, H, H, and H. Then there will be again repetition CH3, H, H, and H. So this is how we form an addition polymer by combining the two monomers. So you have to practice how to form an addition polymer by linking the small molecules. So this was May 2021 paper.